So problem number 6. I'm beginning problem number 6 on these physics videos, but I need to say something first. Apparently Star is doing something for her Snapchat story, and I'm sitting here awkwardly with my headphones put in. And I'm working on this physics video, and there's this light in my eye, and I don't know what to do, and all my AP physics students are going to hear this, and it's going to be awkward. So anyway, let me continue with the problem. Sorry about that, AP students, but I'm a star. Like an actor star, not like a Starnisha. Okay, this is awkward. Okay, so number 6. A block of mass, 5 kilograms, lies on an inclined plane as shown above. And I just want to label a couple of things. As I told you, the vertical is 3, the horizontal is 4, and we have this angle theta here. Now let's be kind of clear. Let's set up the free body diagram. We're trying to pull this up with constant speed, which means the force is balance, because we're going with constant speed in a straight line. So we've got a pulling force. We've got the normal force, so the normal on the mass due to the plane. We've got the weight of the mass due to the earth. And let's split up our components. We're trying to pull it up the plane, so that means we've got a force of friction here on the mass due to the plane. And then we have WME cos theta and WME sine theta. Now, since the force is balanced, let's just write down the balanced force equation. So the pulling force fights the friction force, and it fights WME sine theta in order to balance. Continuing this, FP equals, now I'm going to plug in a couple things. I know that normal equals WME cos theta. That balances WME cos theta. So what I'm getting is the pushing force up the plane needs to balance friction, which is mu times WME cos theta plus WME sine theta. Now let's plug in some numbers. So the pushing force is going to equal, this is 0.3. I'm going to make that 3/10 for mu. And then WME, that's 5 times 10, which is 50. And the cosine of theta, using SOHCAHTOA, is going to be 4/5 plus 50 sine of theta is going to be 3/5. And so when we actually work this out, we're going to end up getting 42 newtons worth of force. And actually I need to be clear in my parentheses. The parentheses go here and here to separate this out. So I'm going to end up getting that this part is 12 and this part is 30. So I'm getting a total of 42 newtons worth of force. And for number 7, in the absence of air resistance, an object is dropped near the surface of the Earth. So let's be clear. The speed of the object as it falls? Nope. The object falls 9.8? Nope. Nope. And nope. This would be true if this were just meters per. If the derivative of the velocity, this would be right. But it actually turns out choice A is the only answer that actually works. And then for number 8, we've thrown a ball into the air parabolically. We've let it go. There is no air resistance. So what that means is the acceleration always downwards. The net force always downwards, because the net force is mg and the acceleration is always g for these projectile motion problems. Then for number 10. So here, I reach a height h. I don't have time, and this is if I'm fired vertically. We'll say v squared equals v naught squared plus 2gh. V naught is 0, so h equals v naught squared. So I should say 0 squared. And this is, let me start this again. I fire something into the air, it reaches a height h. So I have v squared equals v naught squared minus 2gh as the height id. H is the height, and this is the equation we use because we don't have time. Now this is 0 at the top, so I get that v squared over 2g is the height we reach if we fire vertically. Now let's figure out the height if we fire horizontally. It's going to be actually kind of a similar equation. I'm going to skip a lot of steps here. So now my vertical speed is v naught squared sine of 45 squared over 2g, and that's going to give me v naught squared over 2 times 1 over 2g when I simplify this. I'm trying to say versus that. So what I'm ending up getting is that I get 1/2 v naught squared over 2g. I know that this part is equal to h, so I end up getting half of my height as my answer. So that's questions 5 through 10.